So let's say we have something like this. Oh my goodness, we have x's and we have y's. Very scary. How are we going to deal with this? Well, there's one nice way to deal with this. X is a variable. We might want to consider what happens as we plug in different values for x. Y is a variable. We might want to consider what happens as we plug in different values for y. But we could just say, hey, whatever y is, it's a number. Whatever x is, it's a number. Let's just multiply. So let's try that. Many ways to do it. We can distribute. We can distribute in a different way. We could take this times each of these pieces, or this whole thing times each of these pieces. Or we could do first, outer, inner, last. Or we could just take all four in whatever order we want. Let's take the first terms, 6x squared. Now the outer terms, that's going to be 9xy. The inner terms here, well, we have minus 2 times 2, that's minus 4. And that's times yx, or xy. And then, well, I can write that as a plus or minus. Let's write it as a minus 6y squared. Because minus 2y times 3y gives us minus 6y squared. We can combine these. 9 minus 4. And that's our answer. So nothing really too scary, except you might say, well, what is y? Well, I don't really care. I'm kind of done with the problem. We don't know what y is, so we can't really go any further here. If we knew what y was, if we knew what both y and x were, we would actually get this down to a single number, but we don't, and that's good enough. What happens if we have something like this? This might scare you. Well, fractions are fine. There's nothing against or nothing different about fractions. We still have this rule. Let's use this rule instead of multiplying out using FOIL or distributive laws. So what would I get? Well, I get x times x plus 2 times x times 1/2, and then plus 1/4. Why 1/4? 1/2 times 1/2 gives me 1/4. So what do I get? I get x squared plus x plus 1/4, and that is my answer. So just some extra examples involving polynomials in situations where you might get scared.